Everyone. Now let's look at these questions that we are going to solve for P1 geometric progression past paper topical questions. This is the first question. I'll just have a quick overview. A geometric progression has first term A does not equal to 0, common ratio R, sum to infinity S. There is another geometric progression, first term A, common ratio 2R, sum to infinity 3S. So we are using one single formula. This is the data for the first series. This is the data for the second series. S is A over 1 minus R, 3S, because the sum to infinity is 3S. That is A over 1 minus 2R. So what I did is that I made S the subject, which already is the subject. I replaced it over here. I cancelled off the A's. It doesn't make a difference because A does not equal to 0. Now we know that whenever there is a possibility of taking common, so taking common is always better and complete as compared to cancellation. Now let's say in this example, c square minus 4ac is equals to 0. That's the complete solution. What if the question is worded in such a manner that c does not equal to 0? So if you want to get rid of c's, you can, because c does not equal to 0. Over here, if I wanted to get rid of A without taking common, I can, because A does not equal to 0. And then I solve, I get R is equals to 2/5. A word of concern, whenever it's a question of sum to infinity, naturally it has nothing to do with AP. It has everything to do with GP. It is necessary that the common ratio should lie between -1 and 1. Maybe you get a question in which there is a quadratic equation. You get two values of R. R is 3/5, R is 2. Which one will you accept? If it's about sum to infinity, you will only accept this one. You will reject this one. Why? Because it is exceeding this particular range. Now let's look at this question. The question says a geometric progression in which all the terms are positive. That means if you get a quadratic equation, you get a positive common ratio, negative common ratio, discard the negative, accept the positive. In which all terms are positive has a sum to infinity of 20. The sum of the first two terms is 12.8. Find the first term of the progression. Looks like a simultaneous equation question. Why? Because A is unknown as well as R is unknown. So now I'll write sum to infinity is A over 1 minus R. Sum to infinity is 20. A is A 1 minus R. That is equation number 1. The sum of first two terms, A plus AR, no need to use the formula. Just simply add them up. A bracket A plus AR is equals to 12.8. A common 1 plus R is equals to 12.8. That is equation number 2. Now over here, if I make A the subject, A is 20 into 1 minus R. Over here, if I make A the subject, that is 12.8 over 1 plus R. So now equate the two. 20 bracket 1 minus R is equals to 12.8 over 1 plus R. 1 plus R into 1 minus R, that is 1 minus R squared. That is 12.8 over 20. So that is 128 over 200. How much is that? That is 64 over 100. So 0.64. 0.64 is over here. This is 1 minus R square. R square is 1 minus 0.64, which is 0.36. So therefore, R comes out to be plus minus 0.6. All good? So now it says all terms are positive. Therefore, common ratio is positive. Therefore, only, and do write these statements. Why you are rejecting, why you are accepting. Only accept R is equals to positive. R is equals to positive 0.6 since all terms in GP are positive. So R is 0.6 and this is the sum to infinity formula. So therefore 20 is equals to A over 1 minus R. That is A over 1 minus 0.6, which is A over 0.4. So therefore A is 20 into 0.4. Therefore this comes out to be 8. That is the working for this particular question. I'll do some questions. I'll then pause so that you can copy it out. Okay. Now this thing is there. 3 geometric progressions. There are 3 different geometric progressions. P, Q, and R. are such that their sum to infinity are the first three terms respectively of an arithmetic progression. Now, what they are doing is that we have to calculate three sum to infinity, just write them down and create a GP, create an AP. Now, first of all, over here, the first progression is P, it's 2, half, half, 1/4, and so on. So therefore, sum to infinity is A over 1 minus, what is R? Half. This is exactly the same sum to infinity that I used in yesterday's example. So this comes out to be 4. Sum to infinity of Q, therefore this is A over 1 minus 1/3, that is 3 over 2/3. So therefore this is 3 into 3, 9 over 4, 9 over 2, 4.5. Find the sum to infinity of the progression R. So now it says P, Q, and R, right? In this order. So therefore, the sum to infinity of P is 4. This is 4.5. There is an addition of 0.5. Therefore, the next one should be what? 5. So this is the sum to infinity of series R. Is this thing clear? 4, 4.5. The next one has to be 5. And now it says, given that the first term of R is 4, so second one, sum to infinity is A over 1 minus R. Sum to infinity is 5. This is 4. This is 1 minus R. 1 minus R is 4/5. Therefore, R is 1 minus 4/5, which is 1/5. So first term is 5. First term is 4. Common ratio is 1/5. What are they asking? Find the sum of the first three terms. Either you can use the formula or just write it down and add it up. So now the first term is 4. The next term is 4 into 1/5. The third term is 4 into 1/5 square. So this is 4. This is 4/5. This is 4 over 25. Add it up, and then you get the sum of first three terms. Or you can use the formula. Something like this. Question number 35. It says the sum of the first term of a progression is 4x, symbolic. Second term is x square. There were two parts. We are focusing on the second part. For the case where the progression is geometric, that means the first part was for the case where the geometric is arithmetic. For the case where the geometric is progression is geometric with a sum to infinity of 8, find the third term. So now first term is 4x. Second term is x square. Therefore, common ratio is x square over 4x, which is x over 4. And first term is what? That is 4x. And sum to infinity is a over 1 minus r. And sum to infinity is a, and this is 4x over 1 minus x over 4. Let me simplify it further. This is 4x over 4 minus x over 4. This is 4 into 4x, 4 minus x. This is 8. And then you simplify. I think it's a linear equation. 8 4s are 32 minus 8x is 16x. 32 is 16 plus 8. That is 24x. Therefore, x is 32 over 24. 8 4s are 8 3s are. So this is 4 over 3. That is the value of x. Are they asking x? No. They're asking for the third term. So that means 4 into 4 over 3. That's the first term. 4 over 3 whole square. That's the next term. And then based upon the ratio, you can find the third term. All good? This one, the question says the sum of first and second terms of a GP is 50. The sum of second and third term is 30. Find the sum to infinity. Did we solve a question like this? I think so. It was not related to sum to infinity. It was related to A and R. Let's have a good double check. So now, first of all, I'll write A plus AR is 50. This is equation 1. And AR plus AR square is 30. That is equation 2. Let's take A common. 1 plus R is 50. Let's take AR common. 1 plus R is 30. Now, can you realize, did we solve something like this? Are you sure? Yes, we solved something like this, in which we thought out of the box and we took this thing common. So now 1 plus R is 50 over A. 1 plus R is 30 over AR. 50 over A is 30 over AR. AA cancels out. Therefore, R is 3 over 5. When R is 3 over 5, let's find A. 1 plus R is 50 divided by 3/5. 1 plus R is 50. I'm using this equation. That is 50 into 5 over 3. Therefore, this is coming out to be 250 over 3. This is 1 plus R. Hence, you can find the value of R, which is 1 minus 250 over 3. I just want to double check one thing. This is 3/5. That is good. 1 plus R is 50 over A. 1 plus R is 50 over A. My bad. This is, I mix up the value of A and this thing. So first of all, 1 plus 3/5 is 50 over A. 5 plus 3, 8/5 is 50 over A. Therefore, A is 50 into 8 divided by, 5 over 8. This is 5, this is 8. That's the value of A. Once you find the value of A, sum to infinity is A over 1 minus R, and then you can evaluate this. So let me pause till now so that you can first copy it. Now, people, let's have a look at this particular question, question 39. It says two convergent geometric progression. Focus on the word convergent. Ye convergent, why are they using it? Convergent is related with sum to infinity. That means even though the series is infinite, infinite series has a finite sum. Provided common ratio lies between -1 and +1, that is what the meaning of the word convergent is. Also remember, there are some questions of geometric progression, arithmetic progression, that is also linked with trigonometry. That would be coming up later. P and Q have the same sum to infinity. That's P, that is Q. The first and second term of P are 6 and 6R. So this is 6 and 6R respectively. The first and second term of Q is 12 and -12R. They both have sum to infinity. Find the value of the common sum to infinity. So first of all, A is 6. Common ratio is 6R over 6, which is R. And over here, first term is 12. Common ratio is -12R over 12, which is -R. Sum to infinity is A over 1 minus R. In this case, A is 6, R is R. Over here, sum to infinity is A over 1 minus R. A is 12. And this is 1 minus R. This is 12 over 1 plus R. They are saying that the sum to infinity is common. They are asking for value of the common sum to infinity. So first of all, 6 over 1 minus R is 12 over 1 plus R. Also, 6 ones are, 6 twos are, I cancel this out. So therefore, 1 plus R into 1 is 2 times 1 minus R. 1 plus R is 2 minus 2R. 3R is equals to 1. Therefore, R comes out to be 1/3. So therefore, the sum to infinity is common. That is 6 over 1 minus 1/3. That is 6 over 2/3. That is 6 divided by 2/3. That is 6 into 3 over 2. 2 ones are, 2 threes are. This comes out to be 9. The common sum to infinity is 9. Clear? Try this one. Question number 42. Let me pause the recording. Now, people, let's have a look at this. It says the common ratio of the geometric progression is R. The first term of the progression, it's a quadratic expression. And the sum to infinity is S. Show that S is 2 minus R. Find the set of possible values that S can take. Now, first of all, sum to infinity is A over 1 minus R. This is first term factorized over here. R minus 1, R minus 2. Now, 1 minus R, if I let it remain as it is, R minus 1 can be written as -1 common 1 minus R. Can I write it like this? Remember these things. that comes in handy. Something like this. A minus B over B minus A, this comes out to be -1. Because you can change sign of any one of them, cancel it out, and -1 will remain. So over here, this -1 multiplies with r minus 2. So sum to infinity is 2 minus r. Sum to infinity is 2 minus r. That is the first part. Second part, since sum to infinity exists, common ratio should lie between -1 and +1. So now over here, they are saying find the set of possible values that S can take. S is 2 minus R. So what I have done is that first I have written R lying between -1 and 1. I multiplied R with negative. What happens? -1 becomes +1. +1 becomes -1. And what else? The inequality flips. So now -R lies between 1 and -1. And if I add 2 to it, so if I add 2 to it, this is what we are getting. 2 minus R lies between 1 and 3. Again, have a look. Over here, -R is lesser than 1, greater than -1. It's better to write it this way. Lesser than 1, greater than -1. And then I added 2 to both sides. So -1 plus 2 becomes 1. 1 plus 2 becomes 3. Therefore, sum to infinity, which is 2 minus r, lies between 1 and 3. It was more of a question of O-level math rather than P1. It was playing around with the inequalities. It was writing in the proper order, adding a 2. That completes the lecture.